All right, so these are problems, double replacement reactions that produce water. And I've already written out the thing and tried to balance it once, but it was getting so stupid that I had to stop. So I will try again now. So I'm going to put a 2 here, and that changes that to 2, and that changes that to 2, and that changes that to 4. And then I'm going to put a 2 here, and that changes that to 4. And we're good there, we're good there, and that changes that to 2, and we're balanced. All right, and so we've made water, and I think that's it. Okay, all right. Does it say, oh, right, the chemical complete ionic and net ionic. Okay, so I took up a little too much room. So now what I'm going to do is separate these all out. So I'm going to have hydrogen, 2 hydrogen, and that's aqueous, plus SO4 negative 2, this is a plus 1, aqueous, plus 2K plus 1 aqueous, plus 2 OH negative 1 aqueous goes to, and now we want to keep the thing that we're interested in together, so 2H2O liquid plus 2K plus 1 aqueous plus SO4 negative 2 aqueous. All right, so that's a complete ionic, and now we want to make that into a net ionic, and so all I care about is whatever is together. So hydrogen is good, I want that. This is a spectator, don't want that. This is a spectator, don't want that. So then I say 2H plus 1 aqueous plus 2OH negative 1 aqueous goes to 2H2O liquid. But now I need to reduce all this down, so I get rid of the coefficients, and I end with H plus 1 aqueous plus OH negative 1 aqueous goes to H2O liquid, and that's it. All right, a little smaller this time. Mixing hydrochloric acid and aqueous calcium hydroxide produces water and aqueous calcium hydroxide. So I make my reaction nice and small up here. So HCl aqueous, because it's an acid, plus calcium, which is a positive 2, this is a negative 1. So CaOH 2 aqueous goes to H2O liquid plus aqueous calcium chloride, Ca, which is a positive 2, negative 1, so we'll need 2, and that's aqueous. And now we're going to balance, so I'm going to go HCl, Ca, and O. And then on this side, I'm going to have HCl, CaO. So this is going to equal 1 plus 2 is 3, 1, 1, O is 2. On this side, we've got 2, and Cl is 2, and Ca is 1, and oxygen is 1. All right, I'm going to go for the Cl first and put a 2 here. Does that make any sense? Not really. Yes, it does. Okay. 2, and so now I have 4 of those, and Cl I have 2 of, and so what if I did a 2, well, let's see, did it change anything else? Nope. And so 2 in front of my H2O to make a 4 and to make a 2, and I think I did it. 4, 2, 1, 2, 4, 2, 1, 2. Great. So now I make my my complete ionic. So 2H plus 1 aqueous plus Cl negative 1 aqueous, and there's a 2, plus Ca plus 2 aqueous plus OH negative 1, and there's 2 of those aqueous, goes to 2H2O plus Ca plus 2 aqueous plus 2 Cl aqueous. All right, so now I want to get this into net ionic, and I only care about the water. So this can go, this can go, this can go, and this can go because they're spectators. So 2H plus 1 aqueous plus 2OH negative 1 aqueous goes to 2H2O liquid. Reduce to H plus 1 aqueous plus OH negative 1 aqueous goes to H2O liquid. All right, next one. I'm mixing nitric acid, which is HNO3, and that's aqueous because it's double replacement and also because it's an acid. Ammonium is NH4, and that's a +1, and this is a -1, so that's nice. Produces, and that's aqueous, H2O and ammonium nitrate, so NH4NO3. So now I balance. HNO3, I can keep it together because it's the same on both sides. NH4 is the same on both sides, and then O, and then the H, so HNO3, NH4, and O equals 1, 2 equals 1 equals 1 equals 1. H on this side is 2, NO3 is 1, NH4 is 1, and oxygen is 1. Look at that, it's balanced. So then I break it apart for my complete ionic, which is H plus 1 aqueous plus NO3 negative 1 aqueous plus NH4 positive 1 aqueous plus OH negative 1 aqueous goes to H2O liquid plus NH4 plus 1 aqueous plus NO3 negative 1 aqueous. Ow. Sorry, it hurts. All right, so we just are interested in our liquid, so we get rid of that, that, and that. And so we have H plus 1 aqueous plus OH negative 1 aqueous goes to H2O liquid. Look at it. It's beautiful. Next one. All right. Mixing hydrosulfuric acid, sulfuric acid, and aqueous calcium hydroxide produces water and aqueous calcium hydroxide. All right. So H2S is aqueous because it's double replacement and it's an acid. Calcium hydroxide, this is +2, that's -1. Yep. So CaOH2 aqueous produces H2O plus aqueous calcium sulfide. Ca is a +2. This is sulfate, or sulfur is in group 6, so that's a -2. So that works out. And aqueous, and now we need to balance. So we have H, S, Ca, and O, and on this side we have H, S, Ca, and O. That equals 2, that equals 1, that equals 1, that equals, 2, 2, 4. O equals 2, H on this side equals 2, S equals 1, SCA equals 1, and O equals 1. So I think I'm going to do a 2 here. That would make that a 4. That makes that a 2, and I think I'm done. Yes. All right, so complete. There's 2H plus 1 aqueous plus S aqueous -2 plus Ca plus 2 aqueous plus 2OH -1 aqueous goes to 2H2O liquid plus Ca plus 2 aqueous plus S -2 aqueous, and I want the net, so I don't care about sulfur or calcium. Get rid of those. 2H plus 1 aqueous plus 2OH -1 aqueous goes to 2H2O liquid. Reduce. H plus 1 aqueous plus OH -1 aqueous goes to H2O liquid. This one we are going to skip because benzoic acid and benzoate, we don't know what those are, so that's fine. So that's this part for water. Thanks. Bye.